Hello, this is Dr. Amudapriya, Associate Professor Triply from Rohini College of Engineering and Technology. We are going to discuss about the course protection and switchgear here, and in this lecture we'll discuss about the circuit breakers. So first let us see about what is a circuit breaker. The components which is used for breaking the current flow in a circuit is known as current circuit breaker, and this will be operated with the direction from the relay circuit. The rating it includes the rated short circuit breaking current, short circuit making current, rated operating sequence of the circuit breaker, and rated short time current. So we can have breaking current, breaking capacity is that the maximum value of the current which has to be breaked upon. While considering the making current, it is expressed as a value like a breaking capacity, but it may so happen the circuit breaker may close. In such a cases, the current increase to a maximum at the peak for the first, and then the circuit breaker should be able to close without hesitation as contact touch. Next is the rated operating sequence or duty cycle. This is a mechanical duty requirement of the circuit breaker for operating mechanisms. After this opening operation, the circuit breaker is again been closed for few minutes, and then instantly it will be tripping without any intentional time delay. So this is what is called the rated operating sequence. Next is the rated short time current. This is the current limit which a circuit breaker can carry safely for certain specific time without any damage. And the rated voltage of circuit breaker is nothing but it will be depending upon the insulation system. For example, what stress it is going to withstand, that's the thing. And this will be based upon two high voltage. Other than that, we'll have some high voltage condition, namely sudden disconnection of huge load, like other apparatuses which are connected to the system. A circuit breaker may also have to face lightning impulses and switching impulses, etc. So in such a cases, we'll consider this. So this is what is the thing. So by all these rating phenomenon, we can have the different types of circuit breakers as MCB, miniature circuit breaker, molded case circuit breaker, MCCB. After that, it may be a low voltage or medium circuit breakers. Accordingly, we'll have the medium circuit breakers as air circuit breaker, air blast circuit breaker, air brake circuit breaker, oil circuit breaker, vacuum circuit breaker, SF6 circuit breaker, sulfur hexafluoride circuit breaker, etc. Let us see about the air blast circuit breaker. This is an important type of the circuit breaker, and this kind of circuit breaker operates in air at atmospheric pressure. After the development of the OCB, the medium voltage ACB is replaced completely by OCB. But in countries like France and Italy, ACBs are still preferable for voltages up to 15 kV. Working principle is that the main aim of all kind of circuit breaker is to prevent the re-establishment of the arc after current zero by creating a situation wherever the contact gap will withstand the system recovery voltage. The air circuit breaker does the same but in a different manner. For interrupting the arc, it creates an arc voltage in excess of the supply voltage. Arc voltage is defined as the minimum voltage required for maintaining the arc. This circuit breaker increases the arc voltage by three ways. It may increase the arc voltage by cooling the arc plasma. As the temperature of arc plasma is decreased, the mobility of the particle in the arc plasma is reduced. So obviously voltage gradient will be high enough to maintain the arc. Next, it may cause the arc voltage by lengthening the arc. If length is more, obviously the resistance will be increasing. Next, by splitting up the arc into number of series arcs, this will also increase the arc voltage obviously. The first objective is usually achieved by forcing the arc into the contact. Second objective is lengthening the arc path, which is achieved concurrently with the first objective. Third objective is achieved by using a metal arc splitter inside the arc chute so that you can split it. So this is what is the example for normally closed and normally opened types which we can have obviously. and here we can see that the main contacts, how they are, those are the things. Here for the normally closed type, this is the thing, the current will be entering into this, the contact, otherwise here. If it is a normally, the contacts when they are getting separated, the arc will be a formation. Here the ionized gas will be obtained. This is the process of ionization. If the length is increased, obviously the impact of arc will be getting reduced. There are certain specific advantages and disadvantages over the arc fast circuit breakers. Specifically, the risk of fire is eliminated in this case, and the dielectric strength is very high. The arcing products can be completely removed because it is air blast. And next, the energy supply for arc extinction is obtained from a high pressure air. The arcing time is also very small, but the disadvantage is considerable maintenance has to be made first. Second, it's very sensitive to variations in RRRV. And next, it finds wide applications in high voltage installations. Majority of the circuit breakers are applied for voltages beyond 110 kV only. And next, while considering the oil circuit breakers, there are different types of oil circuit breakers, namely bulk oil circuit breakers, which uses a large quantity of oil. In this circuit breaker, the oil serves two purposes. One is arc extinction, and the other one is for insulating the current conducting parts from one another and from the earth tanker. Such circuit breakers may be classified into plain oil circuit breakers and arc control circuit breakers. So when considering the low oil circuit breakers, it uses a minimum amount of oil, and this is used for arc extinction. The current conducting parts are insulated by air or porcelain or organic insulating material. So there are two chambers in a low oil circuit breaker. The oil in each chamber is separated from each other. Main advantage is that the oil in the second chamber will not get any pollution. Upper chamber, it will be the circuit breaker chamber, and the lower one is a support chamber. And while considering the operation and the normal operating conditions, the moving contacts remain engaged with the upper fixed contact. When a fault occurs, the moving contact is pulled down by the tripping springs and an arc is struck. The arc vaporizes the oil and produces gas under high pressure. This action constrains the oil to pass through a central hole in the moving contact and results in forcing series of oil through the respective passage of the turbulator. The process of turbulation is orderly one, and in which the sections of the arc are successfully pinched by the effect of the separate streams of oil moving across each section in the and bearing away its gases. So the advantages are it requires a lesser quantity of oil, requires small space, reduced risk of fire, and maintenance problems are getting reduced. But it bears a certain disadvantages also, because due to pollution, this oil content will be polluted and it has to be maintained frequently, and then the degree of carbonization, yeah, that's the thing, it will be higher. Difficulty of removing the gases from the container is a hectic task, which involves a more amount of money for the maintenance, etc. And next is the SF6 circuit breaker. While considering the SF6 circuit breaker, it should be taught what is SF6. At this point, now we know the medium in which the arc extinction of the circuit breaker takes place greatly influences the important characteristics and life of the circuit breaker. So while considering the SF6 circuit breaker, in many electrical equipments for insulation, such essential properties of SF6 are the reason of its extensive use in circuit breakers. They are having high dielectric strength, which is the most important quality of a material for use in electrical equipment, and in particular for a brake, it is one of the most desired properties. Moreover, RRRV value or the rate of rise of dielectric strength after the arc extinction is very high. This characteristic is very much sought for a circuit breaker to avoid restriking. The very advantages of SF6 are they are colorless, odorless, non-toxic gas. It's an inert gas. So under normal operating condition, the metal parts in contact with the gas will not be getting corroded. This will be ensuring the life of the breaker and reduces the need for maintenance. Also, the SO6 has a high thermal conductivity, which means high dissipation capacity, and the gas is quite stable. It is non-flammable, so that there is no risk of any fire hazard and explosion. So these are some of the best advantages in cold climate. Supplementary heating or supplemental heating or derating of the circuit breakers may be required due to liquefaction of SO6. This is one of the disadvantage in this case. So this is a diagram which is being used for it. And next let us see about the vacuum circuit breakers. Vacuum circuit breaker, here the quenching medium is a pure vacuum, and we can say that this offers the highest insulating strength so far while quenching the arc. When contacts of a breaker are opened in vacuum, the interruption occurs at the first current zero with the dielectric strength between the contacts building at a rate of thousands of times that obtained with the other circuit breakers. When the contacts of the breaker are opened in vacuum 10 to 7 to 10 to 5 torr, an arc is produced between the contacts by the ionization of the metal vapors of contacts. The arc is quickly quenched because the metallic vapors, electrons and ions produced during the arc condense quickly on the surfaces of the circuit breaker contacts, resulting in a quick recovery of dielectric strength. As soon as the arc is produced in vacuum, it is quickly extinguished due to the fast rate of recovery of dielectric strength in vacuum. So we can see the construction here. So this is what is the construction of the vacuum circuit breaker. Now we have a fixed terminal. This is a N shield which is used for protection, and at the center we do have the electrodes. And here this is a vacuum medium. This is the insulating envelope. The shield which is used for support of the flange. This is a vapor conduction shield, the yellow color covering, and then the bellows of the shield in order to operate it under an varying pressure. And this is how the yellows are being off. And finally the moving terminal. When the breaker operates, the moving contact separates from the fixed contact and an arc is struck between the contacts. The production of arc is due to the ionization of metal ions and depends very much upon the material of contacts. Arc is quickly extinguished because the metal vapors, electrons, and ions are produced during the arc are diffused in short time and seized by the surfaces of the moving and fixed members and sheets. Since vacuum has very fast rate of recovery of dielectric strength, the arc extinction in this circuit breaker occurs with a short contact separation. This is compact, reliable, have longer life, no fire hazards, no generation of gas during and after operation. They can interrupt any fault current. They require little maintenance and are quite in operation. Regarding the testing of circuit breakers, there are primary injection test which concentrates on the motion, travel, speed, acceleration and damping. Thank you.